Hey, what's going on, folks? It's Mike here. Welcome to the next lesson in our Modern C++ series. In this lesson, I'm going to talk about something that's a little bit more advanced, and it has to do with unique pointer. Now, some of this information also applies to shared pointers as well, and well, there's some specifics that we have to get into, but I want to show you a minimal example of something that I've covered in the template series of this C++ series, and that is with some of the default parameters in our template lists when we create smart pointers. So let's go ahead and just make this a little bit more concrete here. That to show an example, here's how we've been able to create a unique pointer, and then we can use make shared, and that creates this integer. Or maybe if we want to allocate an array of things, we could also do that as well, whatever we might want to do. But hidden behind this is a default parameter here. And by default, usually what we're doing when we want to clean up our pointer is delete it. Now, of course, there's two different ways that we can delete. If we're allocating just one single object, then we have just delete. And if we have an array or a block of memory, then we have delete with the brackets. So don't forget that. But what I want to go ahead and show you is how to actually set up this parameter here. And we can see that it's a class. Now, the reality is we can pass in anything that's callable here. And I'll go down to the specification where it exactly says that. And let's go ahead and see. So for the deleter, it must be some type of function object here. Okay, so we could do some other things like pass in a function or a lambda here, but I'm going to just show you with a class how this is typically used. So let's go ahead and try to get things working here with providing a second parameter here, and that is the deleter in our template parameter list. And I'll talk about why we might want to do this as we proceed. So let's go ahead and just create a class here. And typically what you'll see here, or a struct, just so everything's public, is something like deleter. And maybe it's a specific thing we want to do, like int deleter, that will delete our integers. And one way we can proceed in doing this is just by creating a particular function here that's just going to delete integers. Okay, so it'll handle int star and whatever our int pointer is, okay, as the actual parameter. And then we would just call delete on our int pointer here, and then it should work as follows. And just to show that this is actually being called, let's go ahead and say int deleter called. Okay, and I'll go ahead and put end line in here. And let's go ahead and first just compile this, see if I've made any silly mistakes. None so far. And now let's apply this. So we need to set a second parameter here and pass in our int deleter. Okay, let's see if that much works here. And oops, we're getting some errors here. Okay, so it's actually complaining here that we can't use this with make unique. Now there are some tips and tricks that you can to use this with make unique, because as a reminder, in general, when we're using unique pointers, we like make unique. It gives us exception safety. If some exception's thrown, then we know it will clean up anything that had been allocated and so on. But for this particular use case here, we've actually just got to use our sort of new int here. Okay, so this style here. Now, again, there are some more advanced ways where you can allocate some storage and get things working that are also exception safe, but this should work for now. Okay, so that seems to compile. And if I run it, we'll see that int deleter is called before the end of this program from our custom deleter. And if we actually run this with Valgrind, which let's go ahead and do here, the memory checker, we can see that there are no memory leaks here. All of our heap allocated memory here, so for example, with our unique pointer, has indeed happened correctly. And just to again show that that works, let's go ahead and show that we're using our custom deleter, comment out the line that we're actually deleting things, recompile our program, rerun it in Valgrind, and we will see that we are in fact losing memory now, 4 bytes. So one integer was not freed. If you haven't used Valgrind, I've got videos on this on my channel, so you can check that out. But again, the point is we are using our custom deleter here. Now, why might you want to do this though? Why isn't delete just good enough? Well, let me bring in another example here that's quite common here. And I'll go ahead and bring it in from CPP reference. And this is quite common if you've done some C programming or followed my C series, that if you do something with opening files. For example, you always want to make sure, well, if I've opened a file, I want to make sure that I've closed the file. And maybe if you have a specific type, you want to also make sure that you remove that file and that it's deleted. So the point of having a custom deleter is that you can follow a series of steps that might need to take place. And oftentimes you would write a custom deleter if you're working with some legacy API. Say you're working some C code or from a different programming language into your C++. Because otherwise you could just write in your destructor for the object the appropriate code that would clean things up. So that's sort of the distinction and how I think about it. But it has, in some cases, like when opening or closing files or working with C library data structures, been useful to make sure that everything gets cleaned up in a custom deleter. So now you know about this feature and have at least a little bit of insight as to where to dig if you want to try to write some safer code here. And again, if this is going to be something that you're doing often, you might create some sort of alias for this type signature or to instantiate these types to use your particular code base. I could imagine you wanting to do other things, for example, in your struct here, like maybe just having a counter here. So let's go ahead and do that here, counter, and let's go ahead and make this static. And that means we are going to have to set up our int deleter here, counter, this is a type int. Let's initialize it to 0. And then we could do some other stuff like maybe call some function that happens to increment this counter here. I don't know, that's just an idea or one thing that you could also do, or a reason to have these sort of custom deleter functions. But anyways, there's many ways that you can do that and sort of tag your memory and do sort of interesting operations there. Again, you can also do this with shared pointers as well, have custom deleters. So these are just a couple of options. I just wanted to make a quick video on this to show you how to use this feature, because it's actually pretty cool and again, pretty powerful once we are able to start diving into some of the more advanced features of the C++ standard template library and just see what's available. So folks, I hope that was an interesting lesson. I hope this put something new on your radar for C++. There seems to always be more stuff that we can be learning, and well, I covered in this series, so make sure you subscribe so you don't miss it. With that said, folks, hope you enjoyed the lesson. Comment below if you have more questions. Again, custom deleters, if they're of interest, there's some more things we can do, and maybe we can even look at how to use something like a make unique in a future lesson if that's interesting for folks. With that said, we'll see you next time.